In our next section, we're going to talk about Apache Spark, something near and dear to my heart. It's something that I personally have a lot of experience with, and I'm very excited to share it with you. This is a very, very hot, very quickly emerging technology in the Hadoop ecosystem for managing the processing of massive amounts of data in a very extensible way. And there's a lot of really cool features built on top of Spark, like things for machine learning and graph analysis and streaming data and all sorts of cool stuff. So let's dive in and find out what Spark is all about. Let's talk about Spark, Apache Spark to be particular. Very exciting technology. I can't wait to tell you about it. It's something that I use a lot personally, and its power and speed is just something that I can never get enough of. What is Spark? Well, if you go to the official Spark website at spark.apache.org, it will just say it's a fast and general engine for large-scale data processing. That's not terribly specific now, is it? I mean, I could say that about the entire Hadoop ecosystem. But Spark kind of takes it up to a new level. It does give you a lot of flexibility where you can actually write real scripts using real programming languages like Java or Scala or Python to do complex manipulations and transformations and analysis of your data. And what sets it apart from other technologies like Pig, for example, is that it has a rich ecosystem on top of Spark that lets you do all sorts of complicated things like machine learning and data mining and graph analysis and streaming data that we'll talk about more. So it's a very powerful framework and a very fast one too. And it's scalable, just like you would have in any Hadoop-based technology. Spark follows the same pattern where basically you have a driver program, a little script that controls what's going to happen in your job, and that goes through some sort of a cluster manager. And you can use Yarn, but that's only one option. Spark can run on Hadoop, but it doesn't have to run on Hadoop. It can actually use its own cluster manager as well that's built in. And it can also use another cluster manager called Mesos that we'll talk about later in the course. But whatever cluster manager you choose, that will distribute your job across an entire cluster of commodity computers, which is kind of the whole point, processing all this data in parallel, where each executor process has some sort of cache and some sort of set of tasks that it's responsible for. Now that cache is the key to the performance here, or part of the key to performance, because unlike disk-based solutions where it's always just hitting HDFS all the time, Spark is a memory-based solution. So it tries to retain as much as it can in RAM as it goes, and that's one of the keys to its speed. Another key to its speed is its use of directed acyclic graphs, which we'll talk about momentarily. So it is really fast. If you compare it to MapReduce, it can be up to 100 times faster when it's operating within memory, or even 10 times faster when it is limited to disk access. But either way, it's going to be faster than MapReduce. Now, 100 times might be a little bit hyperbolic, but in my experiments, it is indeed much faster than MapReduce. So, given the choice between the two, you would probably want to take Spark over MapReduce. And again, MapReduce is very limited in what it can do. You have to think about things in terms of mappers and reducers, whereas Spark provides a framework, much like Pig does, for removing that level of thought from you. You can just think more about your end results and program toward that, and think less about how to actually distribute it across the cluster. Spark does that for you. And remember when we used TES with Pig? That was a directed acyclic graph, and Spark has the same thing built in. So it too can optimize workflows to actually work backwards from the end result that you want and figure out the fastest way to get there. And that too is key to its speed and performance, which is, like I said, pretty darn impressive. It's also a very hot technology. I mean, there's this whole world around Spark right now. They have their own conferences, several conferences per year, in fact, that are very popular. And it's in very active development right now. It's hard to keep up on all the things that are changing in Spark. Companies like Amazon, eBay, NASA, Yahoo, and tons of others are using Spark today for real-world problems on real massive data sets. So it's not only a popular skill to have, it's a very valuable skill to have. If you know Spark, that's a dang good thing to have in your resume. And the beauty of it is that it's not really that hard. When you start looking at some of the code that we're going to look at later in this section, there's not a whole lot to it. A few lines of code can actually kick off some very complex analysis on a cluster. And you have your choice of using Python, Java, or Scala for programming it. We'll get into the reasons why you might choose one or the other in a moment. But at the end of the day, it's all built around one main concept. It's something called the resilient distributed data set. It's basically just an object that represents a data set, and there are various functions you can call on that RDD object to transform it or reduce it or analyze it in whatever way you want to produce new RDDs. So usually you're just writing a script that takes an RDD of your input data and transforms that in whatever way you want as you go. Now in Spark 2.0, which came out in 2016, they've built on top of RDDs to produce something called a data set. That's a little bit more of a SQL focused take on an RDD, but at the end of the day, it's still built around the RDD. Like I said, Spark has a lot of depth to it. So while you could just program at the RDD level within Spark Core, there are also libraries built on top of Spark that are part of Spark itself. It just comes along as part of the package. So Spark Streaming is one of them, and we'll have a whole discussion of that later in the course, where instead of just doing batch processing of data, you can actually input data in real time. So imagine you have a fleet of web servers that are producing logs. That log data can be ingested as it's being produced into Spark and then actually analyzed across some window of time, and you can output the results of that analysis to a database or some NoSQL data store, whatever you need to do, all with a few lines of code in Spark Streaming. Very exciting stuff. Spark SQL, very, very hot area right now. It's basically a SQL interface to Spark. So again, if you're familiar with SQL, you can just write SQL queries against your data using Spark SQL, or use SQL-like functions to transform your data sets in Spark. This is really the direction that Spark is going in right now. A lot of the optimization work is really focused on the Spark SQL interface, namely data sets on Spark. And that allows it to do even more optimizations beyond the directed acyclic graph, because it can do SQL optimizations on the queries that you're actually running, and it's even faster. So that's kind of the way of the future right now. The way of the present, really, if you're using Spark 2.0. MLlib, very exciting stuff. An entire library of machine learning and data mining tools that you can run on a data set that's in Spark. So, it can be very, very challenging to try to think about how to break a machine learning problem like clustering or, regression analysis into mappers and reducers. You don't have to, though, because Spark's MLlib will figure that out for you. And you can just create very high-level classes for extracting meaning from the data that you have. GraphX, that's the graph in the terms of graph theory. So imagine, for example, you have a social network graph, a graph of friends and whatnot, and you want to analyze the properties of that graph and see who's connected to who in what way and what are the shortest paths and things like that. GraphX provides a very extensible way of doing that. In one of my other courses, we actually go through an example of using that to figure out the degrees of separation between superheroes and comic books. So you can do some pretty fun stuff with GraphX as well, and it's very easy to use as well. So very rich ecosystem surrounding Spark that lets you do a wide variety of tasks on big data across a cluster, and that's why I find Spark so exciting. Now, for our examples, we're going to be using the Python language in this course, and, well, because this is just an overview and we don't really have time to teach you a new programming language as part of this course, we're going to stick with Python because we're using that in some other sections here, and there's a good chance you've already encountered Python code before. It's a lot simpler to use, and the real advantage to using Python in this course is that you don't have to bother with compiling stuff and building jar files and worrying about dependencies and all that nonsense. Python's just a lot easier to get up and running with. But if you do want to end up using Spark in production in the real world, Python's okay to start with and prototype stuff, but you're probably going to want to move to Scala as a programming language ultimately. Scala is what Spark itself is written in. It's a good functional programming model that maps very well to how Spark works, and it also gives you much faster performance and more reliable performance because you don't have all the overhead of Python going on there. Scala compiles right down to Java bytecode, and like we've talked about before, all of Hadoop ultimately runs in Java, so that lets you actually run in the most efficient way possible. Python is in fact a lot slower in comparison. If you were to run the same jobs in Spark on Python versus Scala, Scala will almost always be noticeably faster and use less resources, which means it's going to run more reliably on a cluster and require smaller clusters than you might need for the equivalent Python code. But again, Python, very easy to use, so we're going to stick with that for now. And the good news is that if you do move from Python to Scala later on, it looks very similar when you're dealing with Spark scripts. So for example, here's a very simple real piece of Python Spark code that just creates an RDD, a resilient distributed data set of the numbers 1, 2, 3, and 4. And then it squares them using this little function that takes in each input value and multiplies it by itself and returns the results into a new RDD. It's actually collecting it to a Python object called squared. And if you compare that to the Scala version of that code, you'll see it looks very familiar. So, the syntax is a little bit different. Instead of using brackets, you're going to construct a list here. Instead of using lambda, you just have this different notation here with a little funny arrow. But at the end of the day, it's not very hard to move from Python to Scala. You'll pick it up quite easily, even though Scala might be an entirely new language to you. So with that, Let's talk more about Spark in depth and how it works and the resilient distributed data set.